Hello, welcome back again. And here is another exam question that we're going to answer. Um, A-level further maths, year one. Vectors. With respect to a fixed origin O, the lines L1 and L2 are given by the equations, well, respectively. You can see them there. It says, show that L1 and L2 meet and find the coordinates of their point of intersection. Well, the first thing that we need to do in the set of process skills is to, this is your A and this is your lambda B. So R is equal to A plus lambda B, and we're going to, yes, we're going to say, well, hold on, we've got minus 6 here, plus lambda. So minus 6, and let's make sure we've got everything going. Yeah, minus 6 plus lambda, because here we have minus 6i and plus lambda multiplied by our I component. We've got no j component. So we just have minus lambda. In our fixed point, we've got no j component, so we have to go to our scalar component, so it's lambda multiplied by minus 1, which is just minus lambda. And then we have 11 for our k component, so we've got 11 plus lambda, because it's just times 1k, so we just got 11 plus lambda. And this is our L1. So in L2 we do the same thing and we put it equal to one another because it says from a fixed origin the lines L1 and L2 are given by the equations. And it says show that L1 and L2 meet. And if they meet, they've got to be equal to each other. Or equal to 0, in fact, in itself. So, but we'll take from right-hand side to left-hand side afterwards. So let's do L2. So we've got 2 plus 2 mu. So we have 2 plus 2 times mu. For our I component, for our j component, we've got minus 2. We've got minus 2. And plus mu. And plus mu. And for our k component, we've got 9 minus 3 mu. So we have 9 minus 3 mu. And that's the first part we need to do. Now we need to equate each line. So the first one, I've got minus 6 plus lambda. And I'm going to take all of this from right-hand side to left-hand side. So I've got minus 8 plus lambda minus 2 mu. Well, let's do lambda minus 2 mu. Lambda, so I've got lambda, whoops, that's here. I've got lambda here. If I keep it on the left-hand side, I've got lambda, take the plus 2 mu, this plus 2 mu from right-hand side to left-hand side, it becomes minus 2 mu, and is equal to 8. And of course that's equal to 8. And I'll put the 8 over here because I'm going to just try to cut corners and do my windows surrounding my vectors, do it as I'm doing vectors. I've got minus lambda here on the left hand side, keep him there. So minus lambda minus mu. So minus lambda minus mu, taking mu from right hand side to left hand side, is equal to negative 2, because I've just got negative 2 there, because remember I had no j component in line L1. And finally, I've got lambda plus 3 mu. So lambda plus lambda here, that plus sign is attached to that lambda. And minus 3 mu from right-hand side to left-hand side becomes minus 3 mu. And will be equal to 11 from left-hand side to right-hand side becomes minus 11. And 9 minus 11 is also minus 2. So I can write, therefore, Therefore, this is my end result here. Is equal to, and here we go. Now, from here, I have to solve to find either lambda or mu. So if I just scroll down, I can solve simultaneously any equations really, solving simultaneously to find either lambda or mu. I will try to find lambda. Let us call these equations, so I've got lambda minus 2 mu. I'll use that as equation 1 is equal to 8. So let's just move this out to the way so we can work. So I've got lambda, lambda minus 2 mu is equal to 8. I'll call this equation 1. Yeah. You call that equation 1. And then I also have minus lambda minus mu is equal to minus 2. And that will be my equation 2. And if I add 1 plus 2, 1 added to 2, I'm going to eliminate lambda. So, therefore, I've got minus 2 mu plus minus mu. That gives me minus 3 mu. And 8 plus minus 2, yeah, because I'm adding. 8 plus minus 2, that gives me, oh, that's nice. That gives me 6. 8 plus minus 2, that gives me 6. So therefore, mu is equal to minus 2. Extend the page. Substitute. So now subst mu is equal to minus 2 in equation 1. I'm gonna get lambda minus 2. Oops, minus 2. Why am I putting that in brackets? You put the other one in brackets. So again, it's all in real time. Lambda minus 2 and mu is equal to minus 2, so substitute that in, is equal to 8. So that gives me lambda plus 4 equals 8. Lambda plus 4 equals 8, which means that lambda is equal to 4. If lambda is equal to 4 and mu is equal to minus 2, I can now check the k component to check for consistency. So let me check the k component. So checking the k component, because remember we're in I, j and k, component. And how do I do that? Well, I'm going to go back and look at the question, and the k component is 4. Which is it? Where are we? It'll be 4 plus 3 times mu. I'm looking for 4 plus 3 mu is equal to negative 2. Yeah. So we've got, lambda, because we've got lambda plus 3 mu is equal to negative 2. So using the k component, which is lambda plus 3 mu, which is equal to negative 2, I substitute the values in, so I've got 4 plus 3 times minus 2, because mu is minus 2. And what does that give me? Well, that gives me 4 minus 6, which is equal to negative 2. And that's correct. So that means the equations are consistent. Therefore, I can say equations are consistent and L1 and L2 meet. They meet. And that shows that. The final thing that you will need to do is to substitute the value of lambda into any line, L1. So finally, subst the value of lambda, subst the value of lambda, excuse my writing, in L1. And L1 is, well, here we are. L1 is minus 6 plus 11k. So we've got minus 6, 0, and 11. So let's write it out as vectors. So we've got minus 6, 0, and that is a 6, minus 6, 0, and 11. Yeah, because we had 0 j, only I and k. And here we go. And it was plus, we found lambda to be 4 plus 4 times, that was minus 2, sorry, 4 times 1, because let's go back, 4 times 1 minus 1 and 1, because we had I minus j plus k times lambda. So we had 1, it was 1 minus 1 and 1. And that was all equal to, now we have to work things out. So we have minus 6 plus 4, which gives us minus 2, and 0 minus 4, which gives us minus 4, and 11 plus 4 gives us 15. So there we have it for 6 marks. Okay, and okay, I hope that was understood.